Hello, in this video we will generate the dataset of inverse cosine over the values of x from negative 0.99 to positive 0.999. The inverse cosine is equal to pi over 2 minus inverse sine. So we begin with the inverse sine. So array formula, inverse sine of the x values. And we factor in pi over 2. So this is minus. Subtract this from pi over 2. Pi over 2. So this is the trend line of the inverse cosine from negative 0.99 to positive 0.99 values of x. Then we generate the Taylor Maclaurin Series sum expansion of the inverse cosine, which is pi over 2 minus the expansion of sine, where it is equal to the summation of a times x to the power 2n plus 1, where the value of n starts from 0 to infinity. So, but we're limited only to the data set. So this is just our range. We cannot reach infinity. So we enter the formula for the arc sine or the inverse sine. So array formula, series sum. So this is the expansion of arc sine. The x values, a times the x values raised to the power, starting with, that's 2n plus 1. So 0, n equals 0. So 2 times 0 plus 1, which is 1. That's the starting power. And the interval will be 2 times 1 plus 1, it's 3. 2 times 2 plus 1 is 5. So 1, 3, 5, 7, 9. So the interval is 2. And the coefficient will be this range. Next, we work on the coefficient, which is equal to, start with the coefficient is 2 to the power 2 times n factorial all over 4 to the power n times n factorial squared times 2n plus 1. We begin with the numerator. It is array formula, factorial of 2 times n. So that's the numerator. Next, we enter the denominator, which will be, the denominator will be all over, that's 4 to the power n. 4 to the power n. That's the first part because there are three parts of the denominator. So this is the denominator. The second part of the denominator is n factorial squared. So times factorial squared. So factorial of n, which is this range. So we have two parts now. Then the third part will be 2n plus 1. So times 2 times n, that's 2n plus 1. Now that we have completed the coefficient, now go back to the expression of the series sum. We factor in pi over 2. So minus pi over 2. Now they're all in the same line. The B0, 1.57 match. B1 also, well, close match. As the degrees go higher, there's already an error. We'll calculate these values of B0, B1, B2, B3, B4, B5, up to B8 using LINEST. To do that, we generate the 1 comma x matrix. So here we have the 1 comma x matrix. First, we enter the power. So x to the power 0 to the power 1 squared cubed to the power until x to the 8. So this is equal to transpose from 0 to 8. Now we complete the 1 comma x matrix, which is array formula of the x values raised to the power from 0 to 8. Now that we have the 1 comma x matrix, we can use LINEST, starting with the inverse cosine, which is array formula or LINEST of data y and data x. And now the LINEST of the expansion. So LINEST data y and data x. Our B0, 1.57 matched to our trend line equation. B1, negative 0.955, negative 0.9899. They also match to the LINEST equation. B2 is 0. That's because this is very small. 3.97 times 10 to the minus 16. That's already 0. Negative, there's 1.12 times 10 to the minus 16. That's already 0. Our B3, negative 0.788 and negative 0.32. So they're the same. They match to our LINEST equation. B4. Our B4 is 9.39 times 10 to the minus 16. That's already 0. And negative 1.04 times 10 to the negative 50. That's already 0. B5 is 1.844. Match. It's also match to our trend line. And 0.442 for B6. That's negative 9.69 times 10 to the minus 16. That's already 0. 7.88 times 10 to the minus 16. That's already 0. That's why B6 is 0. B7, our B7 is 1.61. It's just a match. And negative 0.531 is also matches. Our approximation match closely to the actual value. This completes the regression, the Linus polynomial regression of the inverse cosine dataset and the Taylor Maclaurin series expansion of the inverse cosine.